Okay, good morning, guys. So before moving to the next topic of the class, let's finish with a couple of ideas related to net present values and net future values, okay? So what are these two ideas? So give me 1 second. Okay, so let's continue with let's finish the ideas of the net present value and net future value, and of course, the internal rate of return. Okay, there are a couple of things that we need to know. So let's do something that can appear when you're doing real life businesses and then you need to decide between two opportunities. So imagine that you have investment A, and investment A is you need to invest $1,000, and in 1 year you are going to be able to get 1,200. And you have also investment B, where you invest only $100, and then in 1 year you're going to get $130. Okay. So what we can do from here is that we can compute the net present value. So let's compute the net present value of A, and let's compute the net present value of B. So if we do that, this is going to be, let's assume just for simplicity, that my opportunity cost equals, let's say 10%. Okay, so let's assume that the opportunity cost is equal to 10%, just to make it easy. So this one here is going to be 1,000 plus 1,200 discounted 1 period. And this one here is going to be 100 plus 130 divided by 1.1, okay? And if we compute the internal rate of return, as soon as we have a single period, that's an easy way to estimate. It's simply the return, okay? So this is going to be 1,200 minus 1,000 over 1,000. So basically my internal rate of return here is 20%, and my internal rate of return here, and this is the one that is going to cause confusion, is going to be 30%, okay? So if you do this, let me compute this number. So here you obtain 90.91. And here you obtain 18.182. Okay? So now, in terms of profitability, guys, remember the profitability is measured in terms of the internal rate of return. You can argue, you know what? I should do this project because it's more profitable. The net present value rule, larger than 0, so I should do both of them. But you can argue that as soon as this one here is providing you with more returns, so you should do project B. Well, in this case, the question is the following. So let's assume, first of all, that you cannot do 10 times B. Okay, so project B is only 100. You cannot replicate this project 10 times. So in order to arrive to this $1,000 here, and that the maximum amount of money that you have is $1,000. Okay, so those are the limitations. So you cannot replicate B, and the maximum you can invest is 1,000. So the relevant question here, guys, is, okay, if I decide to invest 100 here, and of course I will obtain a profitability of 30%, the question is what I do with the 900 that are left, okay? Then, basically what we need to do in this case is something that comes in this way. So what we need to do is we need to do A minus B. That is basically the amount of money I'm leaving if I invest on B. So basically 1,000 minus 100. So what I do with my 900? Well, I should create with this 900, basically what I'm creating here. The difference between these two is equal to 1,070. Do you agree? So this is what is called the incremental cash flow. So this cash flow here is called the incremental cash flow. And what is interesting, guys, is that this incremental cash flow simply tells you, okay, so if you invest less than the money that you have, this is the money you need to produce in order to be indifferent with this number here. with a project number one, with a project A. So if we compute from this one here, let's take a look to the net present value. So the net present value is called of A minus B is going to be equal to minus 900 plus 1070 divided by 1.1. And my internal rate of return of the incremental cash flow is going to be 1070 minus 900 over 900. Okay, so let's see this number here. This number here provides me 1070 minus 900 over 900 provides me with 18.89%. Sorry, 89%. Okay, and my net present value, of course, is going to be also positive. So let me compute this number. It's going to be minus 900 plus 1070 divided by 1.1. So it's 72.72 equals 72.72. 73, let's say. Yeah, if we round this correctly. Okay, so basically, guys, what is the decision rule with incremental value? So what is 18.89 means? So this tells you, okay, guys, if you want to do project B, what you need to find is a project that is called incremental project where you can use your $900 that produces 18.89% return. If you have this project, you're going to be indifferent between doing B and the difference on A. Right? So the decision rule here is basically simply saying, if this number here is larger than my internal rate of return, than my opportunity cost, okay, what I need to do is basically do project A, do the larger project. Okay, and what is interesting, guys, is if you can add up these two net present values, what you obtain is obviously this value here. Got it? So if you decide to invest only in project B and you don't, and your $900, you simply leave it at the 10%, that is your opportunity cost. This is what you're losing. You're basically losing $72.73 by not doing the project A. Got it? So this is a way, guys, in which you can analyze two projects with different initial investments and different profitabilities, or different profitability factors. Okay, so this is the first topic here. Now let's go to a second topic, and with this, I think we are more or less done with applications of interest rates into net present values, internal rate of returns. There is something more. Okay, so let's start doing this right in the name. So this is the weighted average cost of capital. Also known as WACC. Got it? So let's try to understand this. So imagine, guys, that you have a project, okay? And for your project, you need $100. And this project is going to produce in time, it's going to produce 140. Okay? And how you finance this $100 is divided into pieces. You get the bank, you get a loan. Let's say, and they give you a loan for 40, and the interest rate that bank charges is 10%. And then the other part, the investors cover $60 just to complete the 100. And imagine that these guys request 15%. Okay? So now you have two interest rates here. You don't have a single interest rate. So the question is, how do I make a decision based on these interest rates if this project is a good one or not? Well, in this case, guys, what you need to compute is what is called exactly the weighted average cost of capital. So how do I compute my weighted average cost of capital? is simply going to be equal to the weighted average of the rate. So it's going to be 40 times 0.1 plus 60 times 0.15 divided by total amount of money I'm receiving. So if you do this, we obtain here 13%. Got it? So this one here is going to be now your discount rate. And of course, now we can use the 13%, and then I will say, I do my net present value. My net present value is going to be minus 100 plus 140 divided by 1.13. And then what I obtain from here, let me see, is going to be equal to 23.8938, larger than 0, so do the project. Okay. Now, the intuition is very simple, guys. So imagine, if you have your 40, okay, in time, you need to pay 10% of this one here, so this is time 0. At time 1, I need to pay 44%, because this is, I need to give the 10% to the bank. And to my investors, I need to give them 15% return. So if you do that, this is going to be 69. Okay? So these are future values. So what happens? If I have my cash flow, I have my $100, okay, at T1. So what I have is I have my $100. Remember, debt is paid first. I paid the 44. What is left is 96. Now, once I have 96 is a positive number, I pay the 69 to my owners, to the investors. Then I end up having 27. So what is this 27, guys? This is the net future value. Got it? And remember, guys, the net future value with the net present value are equivalent. And the only thing that I need to do to show that is simply discount this one. So if I do 27 divided by 1.13, what you are going to obtain for sure is 23.8938. Got it? But this is the basic idea. Using the 13%, what you are doing is you're ensuring that you're going to be able to pay the clients, the bank. So this is the bank for the loan. And you're going to be able to pay your investors. Okay? And so that's why the weighted average cost of capital comes handy here to help you moderate this type of projects. Okay, so now what we're going to start, guys, is the next part of our class. And in this next part of our class, what we are going to be developing is something that is known as IOUs. Okay, so what is an IOU? It's a legal document in which one party provides a service and the other party offers to pay. And that's it. It's basically, if you sell me something, I will pay you a given amount of money in a given period of time in a structural way. Okay, one example of this one here that we always use is, for example, a mortgage. Okay, and let's start with a mortgage. That is a special type of IOU. And the mortgage is going to allow us to create all the formulas that we need and understand how this works. Okay, so imagine that we have the following cash flow. So imagine you receive a loan. Let's call this C0. And then you're going to make a lot of payments, end payments. So you do a period 1, you do a payment, and a period 2, you do a payment. And let's assume for the time being that the payments are the same. Okay, so we have the payments, and at time n, you have your payment. So this is n-1, this is period n, this is period 1, 2, etc. So what is you see this is a very simple cash flow. So how do I compute C0? C0 is simply going to be equal to the discounted cash flow. So it's going to be a PMT, 1 plus I, and let's assume that the discount rate is I, plus PMT, 1 plus I squared. If we continue summing this one here, we're going to have here PMT, 1 plus I to the n-1, and PMT, 1 plus I to the n. Okay, I will just simplify this one. I will call S is going to be C0. I will call A to be PMT over 1 plus I, and I will call Q is going to be equivalent to 1 plus I. Okay, so if I simply rewrite this in terms of these new letters now, so S is going to be equal to A plus AQ plus AQ. So if I do this here, remember just to see PMT 1 plus I cubed. So this one is going to be, the next one is going to be A times Q squared. And then if you continue this one here, the last one is going to be A Q n minus 1. Got it? And what I will do is another trick, guys. I will multiply everything by A. Sorry, by Q. So if I multiply all this side, left-hand side and right-hand side by Q, I will have QS equals A. Let me move this just to make it cleaner. This is going to be A times Q is AQ. AQ times Q is AQ squared. And then we continue this one here. I will have AQN minus 1, and I will have AQN. And what I will do is I will subtract S minus QS. And you can see this cancel out, and the only ones that survive are A minus AQN. Okay, I will just leave S here. So S is going to be equal to A 1 minus Q that multiplies 1 minus Q to the n. Okay, so this is the general formula. Let me develop a little more this formula just to see what we can get, what we can learn from this formula. I developed A and Q. So S is going to be basically, well, S is C0 already. I can put C0 already here. C0 is going to be equal to A. A was PMT 1 plus A divided by 1 minus Q. Q is 1 plus I. And all this multiplies 1 minus, I will keep the Q here, okay? Just develop this part here. You're gonna see why in a minute. So C0 here is going to be PMT 1 plus I over 1 plus I minus 1 over 1 plus I. That multiplies 1 minus Q to the n. So you can see that this one cancels out, the 1 disappears. So finally, my C0 is going to be equal to PMT over I 1 minus QN. Okay, and then we have two cases here, okay, with this formula, two cases. One that is called perpetuity. That simply means n goes to the infinite, okay? And products like these guys, yes, exist always. Gilts, for example, in England. So you buy one bond, and it's going to pay you a coupon, so an interest rate payment forever, okay? Sorry, an interest payment forever. And the idea here is, for example, if you die and you don't want to give the money directly to your kids because you believe they're going to disappear the money, what you can do is you can do a trust and create this type of product. So this means that your kids are going to receive money, the kids of your kids are going to receive money, etc. So this is eternal, it's infinite. Okay, so what is the formula for this one here then? It's very simple. Let's take a look to this formula here. If n tends to infinite, so remember Q first of all. Q is a number 1 divided by a larger number. So Q is smaller than 1. Any number smaller than 1 to the power, so if the power starts increasing, this number here tends to 0. So in the infinite, so this number is going to be kind of effectively 0. So what you end up with is simply, what it will go up is simply PMT over I. And that's it. And this is your formula for this type of products. So let's assume, let's do one example. You want to give your kids $100,000 per year. Okay, and assume that the interest rate per year is around 4%. So how much money you need to give to the trust? How much money you need to have now to give to the trust? Well, according to the formula, it should be 100,000 divided by 0.04. And this should be equal to 4 million. 100,000 divided by 0.04. No, 2.5 million. So this is what you need to have. Now, and this will ensure, guys, that your kids and the kids of your kids are going to receive this money. Okay, so this looks good. However, if you understand a little economics, you can realize that, you know what, well, that looks good. Perhaps this $100,000 is good for the next 20 years. But after that, due to inflation, et cetera, so this one here is going to disappear. So $100,000 in 100 years is perhaps like the equivalent to $1. We don't know. Got it? So that's why what you can do normally, if you simply change, instead of payment, you increase payment plus 1 plus pi. Pi, let's assume pi is, or let's say G, is inflation rate. So you can adjust these cash flows to consider inflation. So if you do that, guys, so what I'm saying is basically, what you need, if you want to compute the formula, what you need to do is basically add 1 plus G here. So, and 1 plus G squared, etc. And G is equal to the inflation rate. So if you do that, you do all the math, you're going to arrive to a formula like this. Now, if we consider inflation, that I call G. So my formula is going to be simply C0 is going to be equal to PMT I minus G. So this is going to be my formula. So let's continue with this example. And now let's assume that inflation is going to be equal to 2% per year. So how much money do I need to put in order to ensure that you're going to receive a value that is adjusted by inflation? Well, C0 is going to be, I want to give you $100,000 per year that is going to be growing with inflation, divided by 0.04 minus 0.02. So now this one here is going to be equal to $5 million. So this is the amount of money, guys, that you need to deposit now in order to provide your kids $100,000 in period one, $100,000 times 1.02, etc. So this money is going to be growing according to an inflation estimated to be 2%. And then there are many other variations of the model, but these are the two more important, the most important two examples that we can say. Okay, let's continue with this model here. Let me copy this model here in the next page. And we are going to talk first of all about annuities. And these are the ones that we really use a lot. Now, how this works? So basically means that n is smaller than infinite. So can be, if you buy a mortgage, if you get a mortgage, it can be 360 months, for example. It can be 2 months, can be whatever months, but it is finite. N is finite. Okay, so if n is finite, so we have, let me remember the formula. This is going to be PMT over I that multiplies 1 minus QN. Okay, so now n is a finite number, so I can develop this part of the formula. So C0 is going to be PMT over I that multiplies 1 minus 1 plus I, all this to the n. All right, so if I do simple algebra, PMT over I is going to be 1 plus I to the n minus 1 over 1 plus I to the n. Okay, so finally, guys, C0 is going to be a function of the payment and this ratio here. What is called is it's called factor simply. Yes, over I that multiplies 1 plus I to the n. So this is your final formula. Okay, now in real life, guys, what you want to compute is the payment. Okay, you know that the C0, you know I need 500 $1,000, what is going to be my payment if I have 360 months and an interest rate of 4% per year, for example. Okay, so what we do normally, the way we find this formula is simply PMT. So I do PMT equals C0 that multiplies I times 1 plus I to the n over 1 plus I to the power n minus 1. So this is the formula that we're going to be using all the time. And this part here is what is called the factor. This part here is what is called the factor. Okay. So let's do one example. So let's assume the following. Let's assume the following. So we have the following example. So let's assume, guys, that my present value. So this one here also, guys, is called this C0 is called the present value or principal. Let's assume that PV, also called principal, equals $9,000. We'll do a very small example. Assume that my interest per year is equal to 26.82%. Let's assume that my loan is going to be paid monthly for 8 months. And that's it. And then my question for you is going to be simply, okay, guys, give me the payment. Okay? So first of all, what we need to understand is if I'm going to be making payments, monthly payments, and I have the annual rate, I need to first of all find my monthly rate. So this is simple. Remember, this is compounding interest rate. So what is the interest rate for 1 month? It's going to be 1.2682 to the power of something minus 1. So up goes 1, down goes 12. If you do this, what you get is, the factor is going to be more or less 0.02. Sorry, the interest rate per month is going to be more or less 0.02. Okay. Now, once you have this number here, you have n, you have the interest rate, and you have the principal. So you can compute the payment. Let's compute first the factor. So my factor is going to be equal to I 0.02 that multiplies 1.02 to the power 8n divided by 1.02 to the power 8 minus 1. Got it? So if you do this, let me see what factor we get. I get a factor of 0.13651. So I have this factor, and then now I can compute my payment. My payment is equal to PV, $9,000. That multiplies 0.13651. So my payment, my monthly payment, is going to be 1,228.588. Okay. So you know how much you're going to be paying for the next 8 months when you have an interest rate of 26% per year. That is an equivalent of 2% per month, more or less, and a principal of $9,000. Now, what is next, guys, is that what you're interested is basically understanding my schedule. So how much I will be paying, how much is going to be part of the principal, how much is going to be interest, etc. Okay, and that's why what is called an amortization table. And it's very simple to build. I will do the first 2 lines by hand, and then we'll do this in Excel, right? Okay, so how the amortization table works? It works in a very easy way. So let's do principal. Okay, the order can change, but let's assume that we want to do this. Principal, I have the interest payments, I have capital, and I have my payment. I know that my payment, and then of course I have month 1, month 2, month 3, etc. Of course, I have my payment that I know how much this is going to be is 228.588, 1228.588, etc. Okay. So the principal, the first principal, guys, is my $9,000. Okay? So this is the amount of money I started. Now, what you first compute is the interest. So what is the interest that you need to pay for month number 1? Is simply the principal times the monthly rate. So this one here is going to be 9,000 times 0.02. And if you do this, you obtain an interest of 180. How do you compute the capital? The capital, guys, is very simple. It's simply, it's the residual value, is the payment minus the interest gives you the capital. So 1,228 minus 180 gives you the capital. If you do this, you obtain 1,048.59. So that's what you get. Okay, so we have finished the first line. So now for the second period, how much money you owe to the bank? Well, I owe to the bank my principal minus my capital. So 9,000 minus 1,048, you obtain here 7,951.41. Okay? And then we repeat the process again. So how much money I will pay in interest? Well, how much money you owe to the bank is going to be 5,951.41 multiplied by 0.02. This is going to be equal to 159.03. And if you make the difference between payment minus the interest, you obtain 1,069.56. And as you can see, guys, that the capital will start increasing and the interest will start decreasing. Got it? And let's do what is left from this table using Excel. Okay, so here we have the numbers that we have that I have provided you in a whiteboard. So I have my PV. I want a loan of $9,000. My interest, my annual interest is going to be 26.82%. So let me make this bigger. So I have 8 months to pay back everything. So I have here my formula. The one that I've done before is 1 plus 26.82 to the power of 1 over 12 minus 1. So this is my interest, my 0.02. My factor, guys, this is the formula that I developed in class. Okay, so it's just replace the values and then you're going to find the results. And then your payment, that is simply, if you take a look to what is that, is simply the principal times the factor. So my payment is going to be 1,228.59. Now, Excel has a way of directly doing this without doing the factor. So use the PMT command. You just need to be sure that B4, what is my B4? My interest rate here is in interest rate, in percentage terms. So that's why I'm multiplying 0.02 percentage terms. So this is 2%. And then you enter the number of periods, B3, so 8, and the principal. You need to enter negative here just to have a positive payoff. Right? So if you do that, you observe, you obtain exactly the same value as the one that we have obtained before. Now, this is my amortization table. So I have my principal, my interest, my capital, and my payments. So you know that the payments are going to be always the same. So I simply do this equal this one, and then F4, just $, to fix it. So it's going to be the same for all the period. If you move the cursor here, appears a black cross, double click, and then you copy this up to this point here. So this is always going to be that. My first principal is going to be $9,000, so equals B1. And then here's where I need to compute first my interest. My interest always is going to be this one here times this one here. And this number here in principle doesn't change. So that's what I need to do, $. So it's going to be what is left in principal, what I still owe to the bank, times the monthly interest rate that in this case I'm not changing. And my capital, guys, is always going to be the payment minus my interest. Okay? And the last formula that you need to be sure that you make correctly is my next principal is going to be $9,000 minus my 1,048 principal. And then you copy this line down here. Once you have this one here, you simply copy these three, the black cross, and down, and done. Right? What you need to be completely sure, guys, when you're doing this stuff is that the last capital amount equals the principal. because this implies that you are going to basically disappear the principal, right? Because next term is going to be the next term that doesn't exist. It's going to be this one minus this one. Okay, 0. Make sense? So that's what you need to be very careful when you do these type of things. Is just verify this number, compare it with this number, and you're going to be sure that this number works. Okay, so this is the way. It's very easy. It's very easy really to work with this type of projects. So you are going to have, I will provide you with a non-formula based example that you need to replicate. But what I will do is I always help you with pop-ups like this, small windows that tell you what is going on, what you need to do, and how you can replicate the results. Got it? So you want to receive that soon. Now, let's do another example. And what I will do now is I will include a flat fee, a commission or flat fee, and let's see what is the impact of that in our effective cost of capital. Okay. Before moving there, let's remember what happens when we have a fee and how we treat fees. So, what is the effect of a fee? Fee or commissions or whatever. So what is a fee, guys? It's simply something you have your C0, and basically you have a bunch of payments. PMT, 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 etc. End periods, PMT, end periods. Okay? What is the fee, guys? The fee is simply, you know what, you need to pay me at the very beginning for administration, whatever you need to pay me a small fee. Okay? So the first thing you need to realize, guys, is that these payments do not depend on the fee. So this implies that the first step in order to compute the payments, you ignore the fee. So basically what you do is, okay, to compute the payments, the cash flow that you use is the regular cash flow without the fee. So you ignore the fee. So C0, and then you have your PMT, etc. So you ignore it. Correct? And so basically this implies that you use our formula. Once you have computed your PMT, then you need to consider, remember that you're paying more than what is stated by the interest rate. Right? So your interest here is I, for example, but you're paying a fee. So the second step, guys, is to compute the effective cost of capital. So indeed, how much money or what is the interest rate that you are effectively paying? Effective cost of capital. And how do you do that? Okay, so once you know the payment, so you have estimated the payment, so you can create another cash flow now with numbers. So this is my C0, and I will say payment is going to be with a var, implies that you know already these payments. So you have computed these payments from here. And then you add your fee. Then you add your fee. Got it? Then in order to compute, remember, in order to compute the effective cost of capital is more or less like computing, the technique is exactly the same as the internal rate of return. But remember also, guys, that when you have a cash flow that is like that has ups and downs, what you need to do first is you need to net the cash flow. Okay, when you net the cash flow, so basically what you are saying is it's not going to be C0 anymore, it's going to be C0 minus my fee. And the remaining part stays the same. Etc. Okay? And then from here, you see, it's a simple cash flow. This is a number, a number, a number. From here, you compute. The technique is called internal rate of return, also in Excel. But in this case, this internal rate of return is going to be my effective cost of capital. And then you can see effectively how much money, what is the interest rate that the bank is charging you. Got it? So this is what we are going to be doing now in Excel. So let me go back to Excel. Okay, so I have this loan. Okay, I have a principal of $45,000. My annual interest rate is 25.28. I will pay this in 36 months, so it's 3 years. And that's all the data that I need. Okay? What I need to do is, as soon as I'm doing monthly payments, I need to compute my monthly rate. Take a look to my monthly formula. Monthly rate formula is the same. 1 plus 25% to the power 1 over 12 minus 1. Then you can compute the factor as we did before, or if you prefer, simply compute the PMT. Just compute the Excel, use the Excel formula PMT, and then you obtain exactly the same payment. Now, here's the thing. The bank is telling you, oh, you know what? You need to pay me a 2% flat commission. So, and you pay the commissions at the very, very beginning, right? As I told you guys, in order to compute your cash flow and your payments, you don't consider the flat. You know, you simply ignore this for a time being. Okay, so I'm ignoring that, and what I've done here is exactly what I've done in the previous example. My payment is going to be equal to this number here, and it's going to be always the same. So that's why you simply, if you take a look, it's exactly the same for all the 36 periods. Then my principal at the beginning is my $45,000. And then my interest, this is the one that you need to compute, is always going to be what is remaining as principal times my monthly interest rate. That's why the monthly interest rate is fixed, because I'm assuming in this example the interest rate doesn't change. And my capital is simply the difference between the payment and the interest. And then you get your capital. You simply copy, you need to do this one here. It's going to be my principal minus my capital, give me this number. And then you create all this line, and then you simply click, goes down. And then if you see down, guys, remember what you need to compare always is this number with this number, just to be sure that you are closing the deal, closing the loan. So this is a correct cash flow. Okay, so this is the first step. So this is going to be your amortization table. So you're okay with that. Now you need to understand how much money you are paying. What is your effective cost of capital? Because you are being charged a 2% flat commission, okay, that you're going to pay at the very beginning. So, and that's what we do. Okay, now this one here has a different purpose. It has nothing to do with the payments. What I'm trying to compute is what is the interest rate that indeed I'm paying. Okay, according to a bank, I'm paying 25% per year. But is this true? Okay, let's prove it. So the first thing to remember to do, we net the cash flow. Netting the cash flow implies also, I put that net already here. So netting the cash flow, implies this is my $45,000 minus my 2%. So this is the effective amount of money I'm getting in period one. Netting, instead of 45, I have 44,100. So this is the value that you put here. And after that, all the cash flows that you have computed previously, I'm putting this negative because this is the money I received. This is the money I will pay. Once I have this table here, guys, you see up to here, what I do is I simply use the IRR technique. Take a look. Is an IRR of all this cash flow, and I just provided a guess of 0.02. You don't need to do this. Excel is getting smarter and smarter. And so this is what Excel is telling to you. Guys, your effective cost of capital, it is not a 1.9%. It is actually percent per month. It is actually 2.02 per month. If you analyze this one here, so you're not talking about 25.28%, you're talking about 27.14%. That is basically 2% above that. Right? So that's the way, guys, that's the way in which you can understand what is your effective cost of capital. Got it? Okay, so let me move into another example. And let's do a couple of examples, and then we do the remaining examples in class. Let's do a prepayment. Okay, so let's see how this works. Let's assume, guys, that we have the same loan as before. I have $45,000, 25.28%, 36 months. I compute my interest rate that is monthly, my factor, and my payment. And I have my 2% flat that I can use only. I use this one only for seeing my effective cost of capital. I haven't done that. You can do that. Now I start the same, 45, etc. And then imagine, guys, that you at the end of period 6, You know, the bank tells you, hey guys, you know what? Sorry, this is, yeah, this is good. You know, they tell you, you know what? I want to pay everything. Okay, so imagine that the 16th day of the 6th month, I say, you know what? There is a, what is that here? This is not I want to pay all. Oh yeah, I understand what is this example. So what I'm saying here, guys, this is the, here. Yes, okay. So let's assume this is a normal regular 6 months. So if you are in the 6th month, so you arrive here and then you should pay here and then you continue paying for 30 more months. But imagine that you are in the 16th day of the 6th month. Okay, so you have paid already from 1 to 5, right? And then in the 16th day, you decide, you know what, I want to pay all my debt. So what I'm telling you is how much you need to pay, right? So if you compare these two tables, guys, this table here up to 5, is exactly the same up to here. Got it? So what you need to understand first of all is what is the interest rate? Because I will not wait until the end of the month to pay this if I have the money now. I want to pay it now. So what I need to compute is what is the interest rate that corresponds to 16 days? Got it? And this is exactly what it is. So I have my monthly rate, and I just want the 16-day rate. So that's why it's this rate that is 1 month, 30 days, is to the power of 16 minus 30. So this number here, I just keep it in mind, and I will use it in a couple of minutes. So what happens when you arrive to month 6? You can see the debt is exactly the same as here. However, what you need to understand is, okay, you know what? You tell to the bank, I want to pay everything that I owe you. The bank is going to tell you, okay, perfect, no issue. Well, hopefully no issue with the bank. There are some countries, guys, that you cannot do prepayments without paying a penalty fee. But let's assume that we're in USA, and in USA you can do prepayments without any penalties. Got it? So the bank is going to tell you, okay, so you need to pay me the interest that corresponds to 16 days. How do we compute that? Well, it's going to be the $40,000 that you owe to the bank times the interest rate that corresponds to these 16 days. You go here. So this is what you need to pay to the bank. Now, in this case, what you do first is you say, okay, how much money I need for the capital? Well, in order to clean your capital, you need 40,414.7. So this is what I need. So how much money do I owe to the bank? The sum of these two here. 406 plus 40,414 equals 40,821.57. So this is what you need to have now on the 16th day of the 6th month in order to clean your debt, pay the bank, and go happy. Make sense? Good. So this is basically when you have, this is a prepayment. So you want to prepay. If you go in between, you need to compute the corresponding interest rate, and then you simply solve this issue. Now let's do one more. What I have here, guys, is the following. I'm with the bank, and this rate here is a variable interest rate, so it changes in time. Okay, it starts at 25, but in time, you know, it can be adjusted every 6 months, for example. And can be adjusted means up or down, okay, but it will be adjusted. So the first 6 months, my payments are going to be based on this 25.28% per year. And then suddenly, not suddenly, but starting on by the end of the month 6, the interest rate now is going to increase to 28.59. Got it? So instead of monthly being 1.89, it's going to be now 2.12. Right? So what you do in this case is, first of all, I need to compute what is the principal that applies to this new rule. The principal that will be used for this new rule is going to be, okay, what I had at the beginning of month 6 minus what I paid in capital. So this is the new amount of money I owe to the bank. And then I use this one here to basically compute my new payment with a new interest rate. Okay? And remember now that the number of months is not anymore 36 because I paid already 6. I have only left 30 months. Once you have that, guys, you simply replace the numbers. You see my new payment increases, of course, and then everything adjusted correctly. So if you go to month 36, remember you need to compare this number with this number with this number. Make sense? And that one there, guys, is is the change on interest rates and how the change of interest rate work. I think that the remaining ones, we're going to do this in class. Okay, so I will post this video as soon as possible, guys. Okay, thank you and talk soon.